Okay, Aubrey and is anybody else? I think that's it. Aubrey? Okay, here we go. Couple things. Notation-wise. Go to this little diagram that's in the middle of the page on 10-2. Look with me at this little circle. Find the middle of this page. Here we go. Let's talk about some things. They have separated this circle into 3 angles. These angles, angle 1, angle 2, angle 3, are called central angles. Why? Because the vertex is in the center. Eventually, listen to this. Eventually, we'll get to circles where we have like angles that are like this, and this angle is called an inscribed angle because it's still inside the circle, but it's not in the center. So this is inscribed versus a central angle. Got it? Central angle, inscribed angle. All right, let's go back to this central angle thing. Angle 1, angle 2, angle 3. Be quiet. Those 3 should add up to be how much? 360 is a full circle. So 1 plus 2 plus 3 equals 360. That's what they say right here. So if I know 2 of them, I can find the third one. Please be quiet. I've only asked 3 times already. Yeah, be quiet. All 3 of your central angles, or however many there are, maybe there's 7 of them. They should add up to be 180 or 360. Yeah? Those are central angles. Inscribed angles are ones across the circle. All right. This guy. Now, we have other things that are called arcs. Like arch, but without the H, right? It's called an arc. Everybody say arc. Arc. Okay. And arcs are like the outside, the circumference of the circle, just a portion of it, right? So it's a portion of the circumference, okay? And they will label these, like, let's say I'm wanting to talk about PR, the arc from P to R. It will be labeled PR with a little half circle over top of it. That's how you label arc PR. Now, here's my question. Let's say I want PR, but I want the other direction. I want this portion of PR, because I can do that, right? Yeah, so I would have to do another spot. If I want the big portion of the circle, I would have to do another spot. So like PTR or PSR would be the same thing, right? Those would all be this bigger portion PR. Does that make sense?
Is PT considered an arc?
PT is considered an arc, but it would be like this little bit right here. Yeah, PT would be an arc. Yep. Okay, questions about that? Those are arcs. Okay, we have some things called, where are we at here? Let's go to, let's put it up here. Okay.
What's the homework?
Put it down here in the corner. A major arc. Put these down in the bottom corner. A minor arc. And a semicircle. Well, semicircle arc. Major arc, minor arc, semicircle. So I've got this guy going on here. Doot, doot, doot. Let's do that, right? Okay, let's say that this guy is, 60 degrees. Right here. We'll go A, B, C. Okay, draw this picture down in the bottom corner. Major arc, minor arc, semicircle. Trevin, knock it off, please. Yes. Even if it takes till after school, we're getting through it. Major arc, minor arc, semicircle. Okay. We have minor arcs. I'm going to start with minor. Minor is anything that is less than
180.
half of a circle, which is 180. Okay, so give me a minor arc.
2.
AB is a minor arc. What else is a minor arc? BC, because BC would be how big? How big is BC? 120, right? AC is 180, right? Okay, let's go to major arc. Major arc is anything that is greater than 180. So give me a major arc, just an example. AC is going to be exactly 180. Let's go BCA. Can we do that? BCA, right? Or BAC would also work, right? Okay. Semicircle is equal to 180. So that would be like how much? AC or ABC. Can we go ABC and say that that's a semicircle?
Well,
Sure, we can.
Let's go ABC because I.
Sure. ABC would be the top part. AC might be the bottom part. Whatever. Okay? All right, moving on. Go to example 1. Go. To the next page. Example 1. Find the measure of angle X. How many angles are inside of there? How many central angles are there? 4. And they all add up to be? 360. Okay, add up. What is this one right here? 90. Okay, so what's 90, 40, and 85? Go. What is that?
Well, 130 plus 85.
215. Is that true? Somebody do that.
215.
215. And we subtract that from 360. 145 is what angle X is, right? So these add up to be 215. Subtract from 360, you get angle X. Does that make sense? Clear as mud? Good. Go to example 2. Classifying arcs, major, minor, semicircle, find its measure, MQ. How big is MQ? How many degrees is MQ? Is that a major, minor, or semicircle, do you think? Minor, because it's less than half a circle, right? It's less than 180 degrees. How many degrees is it exactly? How do you find it? I want this angle right here. Subtract from what?
180.
These two should add up to be 180, right? Okay. So 180 minus 115 is what? 65 degrees. Yep. And so that is a minor circle or a minor arc. 65 degrees. Yeah? Okay. On the next page, I don't know if you can see this very well, but MNP. MNP is from here to here. That is 180, and that is a semicircle, 180 degrees. Okay? All right, next one, MNQ. MNQ is all the way around here.
265.
Yeah, we know that this guy right here is 65, so it's everything but that 65, right? 360 minus 65? Is that like 295? Yeah? We know that this guy's 65, right? It's everything but that. So 295, and he is a major arc. Okay? Good? All right. Okay, if you have not been listening thus far, you need to listen now. There are 2 ways. You're going to get confused about this. There are 2 ways of talking about the measure of an arc. There is the degree measure. And then there is the actual length measure, like in measurements, there's like inches, centimeters, that type of thing, okay? We have been doing degree measure for an arc. Now we're going to be talking about length measure. If you participated on the bonus question on the test, it's a kind of a similar process to finding the length of an arc as it is to find that, right? Okay? So we'll talk about that. So degree measure of an arc and then length measure of an arc. Let's talk about this. All right, here we go. Number 3, find arc measure in circle graphs. It says the circle graph shown. How teenagers spend their time online. Find the measure of DE. Where is DE? DE is right here. Search engines is DE, and that is 12%. That is not degrees. That's 12%. How do I find out how many degrees 12% is? Because what is percent based out of? Is 100 degrees, right? I want it in degrees, not percent.
0.12 times
360 times 12% or 0.12. What is that? How many degrees is that?
3.2.
What? 43.2? 43.2 degrees is how much 12% should be, right? Do we understand that 12% and degrees are different? Percent degree. Percent's out of 100, degree is out of 360. So 0.12 times 360 will give me the correct number of degrees. Does that look like it might be about 43 degrees?
Yep.
Do you know how much 45 degrees is? Half of 90. If this is 90, 45 would be like there, right? 43 seems appropriate. That is definitely not 12 degrees. Correct? Okay. All right. Now, that was asking for arc in degree measure, not in length of the arc. Okay. They are asking for M of DE. That means the measure of DE in degrees. Okay. Then they will ask for arc length, but not yet. Find the measure of WY. Where is WY? Right here. From W to Y, what is the measure of that arc? In degrees. In degree measure. How do I find it? 90 plus 62, so 152. 152 degrees. Again, it's asking for degree measure, not the length. Not how far is it to walk from here to here, right? Okay, in order to be able to do that, I would have to know what the radius is. They would have to tell me, like, this is 10 inches from there to there, right? And then I can find it. And I'll show you how to do that here in just a second. Okay, so when they're asking for this, they're just asking for what is the measure of the arc. Got it?
Question?
What?
How do you know not to go the other way around the circle?
It will always give you the shortest distance.
Okay.
Good question. Yeah, did you hear his question?
No.
He said if they say WY, the arc WY, how do you know to go that way and not WY this way? It's always the shortest distance from the one point to the other point, right? Okay? So if they instead wanted the bigger distance, they would have to go WZY. Good question. Okay? All right, next. Let's go to, I'm just going to go to example 5 because they give you a formula and I don't like it. I'm going to show you how to do this the easy way. Example 5, they actually want you to find the length. That is not in degrees. That means actually find the distance around the curve of the circle, right? From A to B. So I just want to know how big this is, right? How much that is, okay? I know that the diameter is 14, right? But AB is a portion of the circumference. We know how to find circumference. It is diameter times pi, true? So if I want the whole circle, his diameter will be 14 pi, true? But I don't want the whole circle. I only want 80 degrees of it. So now what do I do? 14 pi, what fraction of the circle am I looking for? Yeah, times the fraction of the circle that I want is 80 degrees out of the full 360. That's how I do it. The whole circle is 14 pi, but now I want to multiply by the fraction of the circle that I want, right? 80 divided by 360. So you can literally go in your calculator, 14 pi times 80 divided by 360. Whoop.
9.77.
9.77, and that is in what units? Meters. There you go. Do you see how that works? Jack, are you my only trig kid?
Yeah,
Do you remember how many degrees 1 radian was from last year?
I do not.
Okay, here's do you know how many radians it is all the way around the circle?
2 pi.
2 pi radians, right? 6.28, okay? 6.28 is equivalent to 360 degrees. I'm going to explain this so that, like, if this is snowing you, just don't listen. If your brain is on track, here you go. If I take 360 and divide by 6.28, that means 1 radian is equal to about 57.3 degrees. So that means that this 80-degree angle right here is a little bit larger than 1 radian, right? What's 1 radius? 7. 1 radius is 7 units. So that means 80 degrees, or if this was 57.3 degrees exactly, this arc would be exactly 7. Does that make sense? But the fact that it's a little bit larger than 57 degrees means it's going to be a little bit larger than 7, right? Okay? So that's how that works. That's how that maths out, right? Okay? Good? All right, let's go do we have another example, or is that it?
So if it was 57.3.
I don't want to do example 6. Let's go to, actually, let's do this one. Let's figure out, instead, I'm going to change number 6. Let's find the arc length if the radius is 5. Let's go 5 centimeters, right? I'm changing this example because I'm not going to give you any like this quite yet. How big is 135 degrees? About yay? Like what quadrant would it be in? Like exactly 45 in the second quadrant. This is 135 degrees, okay? So less than half a circle, right? Okay? If I want to find the circumference of the whole circle, it would be diameter times pi, right? It would be 10 pi. 10 pi is 31.415, blah, 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 whatever, right? 31.4, right? That's the whole circumference, but I only want how much of it? 135 out of 360. Okay, real quick, before we get that far, how many radians is 135? If 1 radian is equal to 57.3 degrees, about how many radians is 135?
About 2.
2.5.
2. 2 radians, right? About 2 radians, little over 2, okay? So I know that this length should be a little over how much?
Two.
A little over 10, because 1 radius is 5. So 1 radius here at 57.3 degrees would be 5. This would be another 5, so it should be a little over 10, right?
How many radiuses there are?
Yes, 1 radian is how many radiuses there are. There are 6.28 radiuses around the circle, yeah.
Okay.
That makes sense? Yeah. 11.8, whatever this is, centimeters. Okay, do you see how that works? Yeah? Yeah? Okay, so you can guesstimate, like, does that even seem reasonable? Yes, it does. It's a little over 2 units of 57 degrees, right? Okay. All right, skip that. I don't want to do that one either. Okay. All right, go to the homework. Homework, page 583.
1 through 11 all, call it quits.
We'll do 18.
Can
What are we
not
in?
get
We're in geometry.
how much we're willing to do?
This is 10.2.
Yep.
Um.
1 through 10 odds.
1 through 10 odds. I don't think so.
1 through 11.
Let's do 1 through 3 all. And then 4 through, actually, yeah, yeah, let's do, let's do 1 through 11 all. And then 12 through 24 evens. Yep,
If we did the others, can we get bonus?
we'll see.
So no, John.
1 through 11 all, 12 through 24 evens.
What do you want to do? How about 22?
1 through 11 all, 12 through 24 evens.
Bonus if I do all the problems.
We'll see. Possibly. Well, I mean, usually what I do is if you do more problems than you need to, I just cancel off if you got any wrong. So it just cancels out any ones that you did wrong. What? I don't know. Maybe tomorrow. I know there's gonna be a lot of people going.
Shouldn't do one tomorrow.
Tomorrow would be a bad idea.
Yep.
We'll see. If there's over half here, we will. If there's under half here, we won't.
Well, we gotta finish phase 2 on Monday,
Yeah.
Oh,
So, check your email if you're gone, and I will send you
What
things.
about Wednesday, Thursday, Friday?
We'll see. Let me stop recording.